Okay, welcome. Please open your books to page 497. This is Solving Inequalities by Addition or Subtraction. And just a reminder, you can pause this video at any time to go back. You can replay, but I'd like you to follow along and do all that I do. So we're going to start this lesson. It's Solving Inequalities by Addition or Subtraction. We're going to look at this real world link. And as you read word problems, I know many of you are really good at circling signal words. But since we're dealing with inequalities, I want you to pay special attention to words that might signal less than, greater than, less than or equal to, or greater than or equal to. So a first class stamp can be used for letters and packages weighing 13 ounces or less. So that really gives us an idea of our inequality. Fisher is mailing pictures to his grandmother and only has a first-class stamp. His envelope weighs 2 ounces. Follow the steps to determine how much the pictures can weigh so that Fisher can use the stamp. So we set up this model. We've got the weight of the envelope plus the weight of the pictures. And the weight of the pictures is what we don't know. So that's our unknown. Well, we do know that the envelope weighs 2 ounces. And the maximum weight the package can be is 13. Okay, so if we were to solve this, remember this is an equation, to get rid of adding 2, we would subtract 2 from both sides. So x would come out to be 11 ounces. The problem is, it says that the package doesn't have to necessarily equal 13, it could be 13 or less. So we're going to replace this equal to sign with this symbol. We use the less than or equal to symbol because it's okay for it to be 13, but it's also okay for this weight of the envelope to be less than 13. So what you're going to learn today is we are going to treat an inequality sign just like we do an equal to sign. It's going to divide our inequality into 2 parts, and we're going to treat it the same. So what we do to one side, we also have to do to the other, and we're going to do the same types of operations. So just like above, we're going to subtract 2 from both sides, but this time our solution, is going to be, when we reset this equation, is x is less than or equal to 11 ounces. Okay, so name 3 possible values of x that will result in a true statement. So what would 3 possibilities for the weight of our pictures be if it has to be less than or equal to 11? So could it be 11? Yep, 11 could be less than or equal to 11. 10, 9, and so forth. Okay, please turn the page. At the top of the next page, you're going to see these properties of inequalities, and they look a lot like the properties of equalities. It says when you solve an inequality, you can use the addition property and subtraction property of inequalities that basically says that if you have an inequality, for instance, 2 is less than 4, that's a true statement, 2 is less than 4. If you add the same amount to both sides, you then would get 5 is less than 7. So it starts true, and when you add the same amount to both sides, it keeps it true. So that property says it is okay to add the same amount to both sides of an inequality, and it's not going to break the relationship. Same thing with subtraction. 6 is greater than 3. That's true. Then if you subtract the same amount from both sides, you get 2 is greater than negative 1. That's still true. The next picture down is what we kind of worked on yesterday when we wanted to tie symbols to words. And we did this a lot, especially with the word at least. Remember when we said the driving age in Michigan you have to be at least 16? That means that you can be greater than or equal to 16. Or in order to ride a ride, your height has to be at least 48 inches. That was another scenario we did. At least 48 is greater than or equal to. What most kids struggle with is when they hear at least, they think less than, but it's really greater than or equal to. At most, if you hear the word at most, I will give you at most $20 to go to the movies. That means your allowance is at most 20. That means 20 is the highest, but it could be less than that. Okay? So I would refer to this green chart whenever you have a word problem. It will help you kind of make sure that you've got the correct ideas or the correct symbols. So we're going to begin today solving inequalities, and we're going to do it exactly like we did equations. So notice we are going to zero out the things that cancel. What we subtract to one side, we subtract to the other, and we get our solution. Okay? Then it's very important to check. This says that our solution is any x value that's greater than 7. So what I'd like you to do is pick an x value that's greater than 7. So let's say 8. And let's try it back up here in the original equation. If x was 8, what's 8 plus 3? Well, it's 11. Is 11 greater than 10? Yes, it checks. Okay. Please go to the adjacent page right in the middle, and please do these two got it questions. Pause the video to complete that, and then restart when those are done. I will check these throughout the class period. Okay, the next step is after we have solved the inequality, we're then going to graph the solution set. So for time's sake, I'm going to jump down here. Let's say our solution is this. A is less than 1.5. We spent time with this yesterday. A is less than 1.5 means it's not equal to 1.5, so we put an open circle, and we're shading everything to the left. Okay, so I'm going to do this one for you. To solve this inequality, we are going to get rid of adding 4 by subtracting 4. And we're left with h is greater than 4 minus 4 is 0. So I talked about this yesterday. When you graph an inequality, you want to put your target number in the middle. You want to put at least one number above and at least one number below. Now it's okay to put more, but all you really need is one above and one below. So if we want all the values of h greater than 0, we are not including 0 because it's the greater than sign. It does not have this equal to part, so we don't shade it in. And everything greater than 0 is everything up here. So our graph's going to look like this. Okay, please pause the video and do D and restart it when you're finished. Okay, and then you'll turn the page. And this example says Dylan has $18 to ride go-karts and play games at the state fair. Suppose the go-karts cost $5.50. Write and solve an inequality to find the most he can spend on games. So he's going to ride the go-karts, that's a given. Plus, he wants to spend some money on games. And he has $18. So he could spend all of the $18 if he wanted. So that's where the equal to part comes in. But it would be okay if he spent less than that, if he went home with some money. Okay. So notice when we solve this, we subtract $5.50 from both sides. And this solution means he can spend on games X anything less than or equal to $12.50. Okay. All right. First thing I'd like you to do is please do 1, 2, and 3 in the guided practice, and then complete the rate yourself. When you've completed that, please raise your hand so that I can spot check your work, and then you may begin your assignment, which is in your assignment guide for lesson 6-6. and it begins on page 501. Thanks.